Hello everyone, I'm Xiao Gang. In this session, we will write about the most crucial middle layer in our framework. It receives calls from Blueprint, retrieves data from the render thread, organizes all the data, and then sends the timing and pixel data of dozens of images to our AnyThread. The AnyThread then returns to our main thread layer, and finally, we return to the main thread layer, call Blueprint again, and Blueprint executes the subsequent logic. In this part, actually here, you can see there is no export redirection, but we want to add an export redirection here. Some friends might want to directly use this class. We'll add an export redirection. This way you can use it directly, use it within this family. There's no problem with that. Okay, before we actually start writing this code, we still need to confirm it. Let's agree on it. Our current processing status, because it's quite complex. If it's not clearly written, everyone will get confused. So we really want this status of ours. We'll divide it into 4. That is record status, survival status, and a reserved field. As for the name, we'll just die sample toy. Okay. Now that we have this enum, let's start working on this multiple shoot thing. Then when we study, many times you first look at the members, then look at the methods. Obviously, in this case, we definitely need to give it a processor type. What do we call it? It's an initialization type. And here our type name has changed, so we copy this name over. Since we already included the header file, so there's no problem. Okay, here we just need to give it an initialization. We give it a long, meaning it's not executing any related work right now. Then we put this variable below. This is a coding standard, but if it's too long, there's no way around it. Just leave space to write it. Then here we give a temporary path. To see where this asset should be placed, we'll just use a txt file. Okay. Next, we need to provide a smart pointer. As for this smart pointer, it is actually in Chinese. It just stores the information for this instance, because this information may need to be used or passed elsewhere later. So this information, then we also have this screenshot delegate. This screen delegate is our delegate. This should be fine. Next, we have replaced this board with the enum, right? Then we prepare the tearaway web colors and the corresponding time for it. We will later receive it in the so-called render thread after we crop it. We just put it in here. Then here we write another one. We can take a quick look. Look here, you will find that in the one shoot section, it has these 2 delegates. So we also need these 2 delegates. First, we pass one to this delegate here. It seems this delegate is needed, so we call it Fellish Web Delegate. This delegate is needed. Then we also need an agent. This agent, it is actually this one here. One short, this agent, our one here. Let's take a look. Actually, it's here. Here, in this agent, we need such an agent. Then this agent is created in. No, it's this agent. Actually, what we need to do is this agent. After the Weibo batch execution, this agent will execute. Then we call it here. Then let's change the name. We'll change should to mute. These delegates here are a bit confusing. Everyone be careful. Our delegate should be this one. Then let's call it symbol. This delegate. As for this delegate should be dynamic should be for blueprint. This should be for blueprint. The delegate it passes in. Okay, so this delegate, we need to bind it here. Listen now. This binding method is also relatively simple. We let it after initialization is complete. We give it a U function. So this U function, as for its name, we'll just call it remember, we give it a method. Okay, and after this binding is done, actually for this Pixian info, we actually don't really need to initialize it. But let's still initialize it here. Actually, it's not really necessary. After initializing it here, we definitely need to unbind it here. As for unbinding, so we just drop it, remove this band on the side. This band is not needed. Is there a small band on this side? Remove this band. This agent is obviously, we need this part to be aligned. After alignment, actually we need a reset operation here. So we may need to clear some information, clean it up. So let's write a reset here. Okay, this conservative protection method, we haven't written anything inside yet. We can put this here, put it here for now. Okay, basically what we need is already done. Then, yes, then we haven't written the specific content yet. And here, we will add another method. This method is for internal use because we need to call it every frame. We need to call this record1 form. So we need to create it. Okay. Now we begin recording here. Now let's walk through this process together. We need to supplement further. First of all, if we don't have this, get this world, get world, then there is a problem. Then, because we must capture within the world, this world must exist. Then if this state currently is not this long, it means that here we might be executing work. Therefore, on our end, we are already in the process of taking a screenshot, so we won't let it execute either. Next, we need to check the size of this picture to see if it's correct. Obviously, we need to pass this information in here. Then, this method we haven't written yet. Let's write it now. Because the data the user passes in might exceed the bounds. What it means is mine is only 1K in size, but you're capturing a pixel outside the screen. So this is obviously incorrect. Then we need to do a simple verification because in this case, it includes two situations. It could be full screen or capturing pixels. So we need to write a method like this. Okay, so this method will take in our type information. If it doesn't work this way, we'll paste the type information over. Okay. Maybe a bit too much was pasted here. Then here, we simply compare this information with our socket information. First, we must obtain this word. If we do not obtain this word, we will have a problem. Then, in this place, we retrieve our viewport information. Obviously, we call the method we wrote above. Just call this method. If we can obtain this information, we proceed further. It can be written like this. If we can obtain this information, we proceed with it. If we do not obtain it, we log a message here. Obviously, in this place, this log indicates a problem. This place, let's paste this log in as well. Let's write the content of the log first. Drag this over here. I won't write the reflection. Okay, so we need a log here. Let's include the log. It should be this log. So, okay, here. And we just need to return a false here. Then, if we get the current viewport size, we need to do a simple comparison. This comparison is to compare whether this point has exceeded the limit. Right? That is the size you pass in. It must be greater than or equal to 0, and then less than the size of our screen you can see. So don't look at how this half is written. Listen to me as I explain. That is, this point of yours, the rectangle you pass in, must be within our screen rectangle. How to be within it? It's actually the idea of AABB. That is the top left corner point of your diagonal. It must be greater than or equal to 0, 0. And then the bottom right corner point must be less than or equal to the screen size. Okay. So that should be about it. No problem. I think it looks like we should subtract 1 here. Right, because if you're comparing coordinates, then you definitely can't equal the number 1920. So this should subtract 1, and then this part should be, the judgment here is mainly about the parameters you pass in yourself must be the top left and bottom right points. And if you pass in other points, then our calculation might not be correct. Right, you must pass in the top left and bottom right points. So your own x1 must be greater than x0 and your y0 must be smaller, meaning your y1 must be greater than y0. So this is just a self-check. Okay, so it should be -1 here. Okay, now that we have this method, only after having this method, then we can continue to make judgments. Then first of all, we must release everything from before. Obviously, we haven't written anything here yet, because I haven't requested any resources yet. So let's request resources first. After releasing, we set our current state to the state of recording. Then we store the path we want to save. For now, just save this path. Then we update this information, update this smart pointer. This smart pointer, we update the picture information for it. Then at this point, same as before, we refresh these existing renderings. Then we proceed to set up such a bonding. Then we can return a value. Okay, so what resources should we put? We'll write what resources to put at the end. Then here we need to prepare a stream shield code bad method. This method is actually the same. For this method, you can see we have declared it now. This function signature. Note that some things cannot be scanned. If you don't scan and they don't match, you won't be able to bind them. Then, what do we need to do here? Let's prepare a lock here. I'm thinking whether I should do this. We need to prepare a lock here. Why do we need to prepare this lock? Because we might have some multi-threaded interactions. Let's write a lock like this. I think the design here is not very reasonable, but we should use it this way for now. It should be fine. Then we do all the work here. All of it goes to another thread to do, because we need to count item by item here. Traversing this thing is particularly troublesome, so we must open it in another thread here. Okay, so the work to be done here is actually to bake this pixel in, and then add it to our place. Add it here, not adding it here this time, mainly to pick it up and bring it over. Because directly learning this one with 4 large pixels is quite complex. We took an address like this, and then here let's lock it first. We need to lock it. After locking it, we'd better take one of these here. This place might make a copy of it. It should be fine to copy it in. Then we prepare an F color like this. In this F color, first of all, we will add something to this thing. So how do we do this addition first? Let's paste the code first, because this thing is a bit complicated. You need to think a little to understand what it means. Okay, good. After we paste it, let's first see if it compiles. Okay, it compiles, which proves it's fine up to here. Let's explain the latter part first, which is the above of this chapter. After this step is making a judgment. Extract specific pixels. Let me show you. Capture specific pixels. Then here we make a judgment on the captured pixels. The total number of captured pixels must meet the setting regarding the length and height in our texture. Once this setting is met, we will not add it to our image set. So here it is adding the corresponding addition, the captured image data. So obviously this part is for making judgments, and the judgment here is actually 鱼头记加加欧汤可东当你 b. But don't look at how it's written inside. Instead, I'll draw a diagram for everyone. I'll draw it like this. For example, let's say we have a rectangle here. There is a rectangle. Then let's draw another rectangle. You can see we have a rectangle here, right? Then for this rectangle, we consider the coordinates of this point to be 11. The reason we didn't use 0, 0 here is because it's a bit confusing. This depends on your personal preference. You can write it however you like, but you need to ensure consistency from start to finish, and this is the entire pixel coordinate. We started from 11. You can see this index starts from 11. So I only want to capture, for example, I want to capture the middle part. I only want the content inside this box. So obviously, the x0 in this x-ling, xe, and this place here is y0. The x1 and y1 here, right? So when you're iterating, how do you confirm whether xy is inside this box? Obviously, your x must be greater than or equal to y0 and less than or equal to y1. And at the same time, your wrong, x-ling, this x must be between x0 and x1. This y must be between y0 and y1. Then you just need to satisfy both conditions simultaneously. Then you are within this box. Then we determine this, whether it is within the x range, then whether it is within the y range. If both conditions are satisfied at the same time, then the pixel data of this point. This f color is added to it. Then when we iterate, we just iterate it in this way. Okay, then we have made this clear here. And there's one point here I want to emphasize again. How does it iterate? It iterates row by row. So you can see the first loop is the y loop, then the second loop is the x loop. It trains the rows first. That is, it traverses like this. It goes like this. Then it traverses like this. Yes, because it adds x. After adding one row of x, then add the second row, then continue adding. So what this means is extract specific pixels. Okay, after capturing it, we add it in. Then you'll notice the reason we added a lock here is because there might be some potential issues. So we added a lock. Okay, and then we have this pixel capture sorting out for you here. This part essentially means we have done an initialization like this. So how do we request to capture this pixel? First, we just need to write this method for capturing this frame. We can take a look at how we are currently using it. Obviously, we are using it inside tick. Used within tick as long as our current state I can find this situation. We find out tick. The code is actually getting longer and longer. Equals this processing recording stage. Then at this point, we initiate a request for this frame and pass this time into it. So how should we write this? Actually, writing this is quite simple. So we can just initiate a request directly here. Then we check if we are currently on the first frame. If we are currently on the first frame, then we let it add a 0 because our 7.10 point is 0. So for the first frame, we discard this float time. Then for subsequent frames, as long as it's not the first frame, under what circumstances it is not the first frame? That is when it already has this data. After having this data, it is no longer in this first frame situation. Then we proceed to add the subsequent one. Then we multiply this time by 1000 because we need to upgrade it. Since what is passed in is a decimal, you need to upgrade it to the millisecond level. This int type is required, and this is actually not very reasonable either, because the addition of this number will actually cause a slight issue. That is a slight problem. It is possible that your render thread hasn't finished rendering yet. Then you might encounter this situation twice. A more reasonable approach here would be to test it. You can use bFirstAdd. That method is also we've already written it this way. So we'll leave it as is. We mentioned there might be a potential issue here, but writing it this way should be fine. Let's just ignore it for now. Okay, so here it means we recorded that this request occurred in one frame. We add the timestamp here, but the pixel data must wait until the next frame. Only after this pixel data arrives will it be added. Okay, now let's write the _1. For underscore, it means we first check if the current type is not in the process of recording, not in the recording state. You see, if it is not in the recording state, it indicates there is a problem. We just return directly. This proves that this part is wrong. Actually, you can bring one here. Bring one for it. You can have it execute directly here. That is execute a false, but we didn't give a reason here. There's no way around this. That is, you can have it execute directly here. That means you ended up failing like this. It didn't actually execute because your processing flow is incorrect. Okay? Prove that if this flow is correct, then first change the state of our generation. Then after changing it, we save this BP proxy because it's just a single wave. Let's save this proxy. We will use this proxy later. Next, we will execute this C task because earlier B1 to B10 were executed at this step. As for the C task, we can just do it this way. We add it like this. Then we start our anyThread thread. Pay attention. This anyThread thread, let it sleep for a quarter seconds first. Because there might be some issues. Because there are some concurrency issues, let it wait a bit first. Wait until all the data is rendered. Then we go in, and finally, we add a lock. Because we might need the stuff inside the hole. Actually, I don't want this place to still be generating. There's still money and data coming in later. So let's just add a lock. Okay, here we directly call this the call method we wrote. Okay, alright. Okay, this way we have generated this data. Whether it becomes successful or not, we actually don't care about it anymore. We'll just have it call back to the mainline layer directly. As for this callback, it must be called back within this task, like this, and this delegate is actually this delegate. No, this delegate is not that one. It's this delegate, actually. Let me check. It should be this delegate. This delegate. Survival issue. It should be this delegate. Okay, it should be calling back this delegate. Then, when this delegate is called, it will activate our method. This method is what we, let's see what we write. This method does not exist. This method, we haven't written it yet. So let's write it now. Right, we should not have written this method yet. Let's write it. Let's put it here. And it actually, let's give it a U function. Let's give it a void like this. And here, we need a boolean to receive whether this WebP was successfully generated. Okay, let's check if there's any problem here. There seems to be a problem here. Let's see where the problem is. Wait a moment, let me check. It looks like there's a problem with what we wrote here. This bracket corresponds to this bracket. Maybe there's an extra bracket. Let's first troubleshoot the problem. This bracket corresponds to this bracket. This bracket should be placed here. So there's no need for a bracket here. Right. Okay, let's confirm first. As for this part, here is the operation we need to perform. Actually, it's quite simple. At this point, we need to remove the screen handle. And we can actually remove it earlier. It should be fine. Then we need to execute this blueprint delegate. Blueprint is this delegate. We pass this result to blueprint. Tell it whether the spawning was successful. Then we finally restore it with reserve. Okay, let's compile now. Let's check where this error is coming from. Obviously, we wrote a semicolon here, which is wrong. Okay, so basically we finished writing it. And did we leave a reset record here? Now let's see what resources we spawned. First of all, if we reset this part, we first need to get this type sorted out, right? Then next we need to handle this if our squats handle. If it is still available, we will remove it. Yes. And at the same time, we need to clear the path given here. Then we clear this. Yes, and clearing this means Clearing, this means holding the image. This is what we need to clear using this data. This way, we have finished writing the entire process. We wrote for 25 minutes. It is really a bit complicated. So let me walk you through it again. It might be a bit confusing. I think it's a bit confusing, and now looking at this code, it can all be optimized because it's been in development for a while, but there hasn't been much time, nor any real need to optimize it. Okay, so first of all, we call this begin record. Whether you're capturing the forward view or the front screen, I just need to get that information from you. Then, once this information comes in, I make a series of judgments, and then we enter this. Let's let this tick enter the recording phase. After recording is done, we will implement the screenshots delegate here properly. Let's also flush the render thread commands. Then, every frame, we will add the current frames time every frame. Then, every frame, we will initiate a screenshot request. For this frame screenshot request, we will activate the screenshot. Pixel data delegate. As for this pixel data delegate, since we may need to perform per pixel data checks, we have created another thread for it here. And we have also added a log to it here. So, in other words, data will be continuously added to our TLV-LV. Then during the recording phase, these two pieces of data will constantly be, in a sense, increased. Each time it increases, a timestamp is added. A set of image data will be added when we no longer need it. We call this end method. This will pass in a blueprint delegate. We will determine whether we are currently in the recording generation phase. If we are in the recording generation phase, then we proceed. If not, we make this blueprint return a false. Then we will start switching to the image generation phase. So, in the image generation part, we initiate the thread for the array. We take all the data we have prepared and generate it within this array thread. After we finish generating, we call back to the main thread to notify that one image generation has been completed. Then we place this GUID here, and at the place where we accept this web batch generation, this delegate is bound by us to our own delegate. We bind this delegate at the very beginning. This delegate is specifically used to handle the callback for this web batch. Then at the web area, this is where the callback occurred. So first of all, we clear these handles, if any, and remove them. At the same time, we let it call back to our blueprint to perform the subsequent work. Then we clear all this data. Actually, this clearing could be placed a bit earlier. Placing it a bit earlier is more appropriate. Yes, if after it finishes, it wants to execute again in the same frame. Placing it here is more appropriate. Because you clear it first, because your data actually, when we are in this under, we can actually start performing the cleanup work. This should be fine as well. Everyone can wait and design this. Then when this while reply is finished, we have all executed it and then we move to our blueprint. Okay, we will test it in the next lesson.